Hi, welcome to geometry class. I don't anticipate a lot of changes with geometry. This is a strategy I've been using most of the year anyway, where we do a very brief introduction. You keep track of your theorems and corollaries and definitions by note cards and just do the work, and then we check it afterwards. So I don't anticipate a lot of changes. I'm going to try to give you a quick overview of section, let's see, what was it, 9.7 today? And then I'll do another one here in a couple of days as well. And we're finishing up circles. We're going to move on then to chapter 11. That's not a mistake. We skipped chapter 10, just so you're aware of that. So I hope everybody's doing well at home, and I hope you're ready to do some geometry. Do your best. If you don't get every problem, it's not going to be the end of the world. Make sure you get the concept. Make sure you do your best. Put some time into it. And study your book, study the resources you have, and contact me if you need further help. So let's look at the board here real quickly. I've copied your examples down from the book. Up until now, we've been looking at angles in circles. Angles form there. The central angle is congruent to the arc it cuts off. The inscribed angle is half of the arc that it cuts off. And if the lines forming them cross inside, we take half their sum. If they cross outside, we take half their difference to find the angles. Today we're looking at something different. Today we're actually looking at the lines themselves, the lengths. Okay, it's a very simple concept. When they cross inside, of course, these are chords because they end on the circle. We're simply going to write an equation here. The product of the segments of one chord, which will be my x, and my 3x, will be equal to the product of the segments of the other chord, so 8 times 6. So here we have 3x squared is equal to 48. Now sometimes you'll need to factor. If you get more than one answer and one of them's negative, remember these are lengths. You'll have to throw it out. Okay, unless this is a square up here or something like that. So dividing through by 3, we're going to get x squared is equal to 16. Taking the square root of both, then x will be equal to 4, which means that this piece is 4 and this piece is 12. So 4 times 12 is 48, 6 times 8 is 48. If they cross inside the circle, if we have two chords, the product of the lengths of one chord is equal to the product of the lengths of the other chord. So that's very basic. A little more complicated, but not much, when we look at secants here and tangents here. Okay, remember that secants begin on the circle, but they extend outside. All right, so let's focus first on the two secants. If we want to find pieces of secants, the rule here says that the external part is multiplied by the entire part of the secant. Okay, so I'm going to take the 4 from outside and I'm going to multiply it. Be very careful because the length here is not 20, it's 5 plus 4 is 9. So I took the external piece times the entire secant, and I'm going to set it equal to here the external part times the entire piece here, which is 3 plus x. All right, so we're going to use our distributive property over here. 36 is equal to 9 plus 3x. Here we're going to get a linear equation. When we subtract 9 from 36, we're going to get 27 is equal to 3x, and x is equal to 9. So x here will be 9. So we'll see that 4 times 9 is 36, and 3 times 12 is 36 as well. So that's our double check. So the external piece times the entire length, and remember to add when you're finding your length. All right, now if we throw in a y here, notice that the y is a tangent. Tangent starts outside the circle and it touches only in one point. Okay, so let's see which one your book wanted to compare it with. Okay, so we're going to ignore this piece right here in the middle right now, and we're going to solve for y because we have values here and here. Now we saw before that a tangent is simply a secant that got away from us. Okay, it started inside here and it worked its way out until it became a tangent. So the same rule applies over on this side, on the secant side, 4 times 9, but over here the external part of the tangent and the internal part, or the whole thing if you will, are both y. The external part is y and the whole part is y, so y squared. So 36 is equal to y squared, which means that y is equal to 6. Okay, so 4 times 9 and 6 squared is 36. So that's really about all you need to know about those. Make sure you review all your formulas on the page 369. That's where they were all outlined. I told you before, I have instructions throughout your packets that I've written for you. On Wednesday, I've included kind of a test. Okay, it's not going to be a test grade or anything like that, but it's going to be a conglomeration of all these rules, the angle rules and the segment rules. And I'd like for you to try to do it without looking, without using your books. Just put everything else away and sit there and figure it out as much as you know. Okay, then when you're finished, when you got all you can, and maybe you can do it all, that's great if you can. If not, then go look in your textbook, get some help, do it in a different color. It's going to help me get some feedback to see what we do know and maybe what we need to spend a little more time on.